Welcome back to another video. In this tutorial, we are going to dive into the concept of coplanar vectors. So now you understand the concept of vectors, position vectors, magnitude or modulus or length of a vector, and then you know what unit vectors are. So now we are going to talk about coplanar vectors. Okay, so here with the coplanar vectors, basically coplanar vectors, they are vectors that are parallel to a plane. So they are just vectors that are parallel to a plane. Okay, so for instance, you have this vector, okay, here A, okay, and you have a plane. This vector is parallel to a particular plane. Okay, so we have a plane here named, let's say, O, B. So parallel, they are all moving in the same direction. So basically, they are parallel to a plane. Okay, so we can talk about vectors on the same plane. So for instance, let's consider vectors A, B, and C. Okay, vectors A, B, and C that are coplanar. Okay, so let's say that we have A, B, and C that are coplanar. Okay, so if these three vectors are coplanar, then it means that one of them can be written in terms of the other. So if these three vectors, okay, are coplanar, it means they can be written in terms, one of them can be written in terms of the other, then we can say that they are linear combination. They are linear combination of the others. Okay, so that is, we can talk of C giving us y a or gamma a, whichever way you call it, plus mu b. Let's consider this as equation 1. Then we can also say that b equals gamma a plus mu c, equation 2. And also we can say that a equals gamma b plus mu c. So where this gamma and mu are scalars. So this gamma and mu, they are just scalars that are multiplying the vectors. So what are scalars? Scalars are quantities that have just magnitude, but they have no direction. So when you have a scalar and a magnitude, then you can talk about coplanar. Okay, so here let's consider an example to clarify this concept. Okay, so looking at this problem, it says if A equals 8i plus 2j minus k and B equals 3i minus j minus 3k, find the vector that is perpendicular to A and coplanar to A and B. Wow. Okay, so once we hear this, we have learned about coplanar vectors. We know what coplanar vectors are. So let's analyze this problem. Okay, so solution: A equals 8i plus 2j minus k and B equals 3i minus j minus 3k. Okay, these two vectors, these two positions, and we have to find the vector that is perpendicular to A and coplanar to A and B. Okay, that is so interesting. So what we do? First, we have to remember that if A is perpendicular, if we are to find a vector that is perpendicular to A and is coplanar to A and B, then we have to begin to think about something. Okay, so if something is coplanar and if something is perpendicular, what do you think about? Okay, so we have to know that it means there is another vector or there is another position vector, say C. So let's assume that we have C equals C1 I plus C2 J plus C3 K. Okay, so that is coplanar, 3 vectors. Okay, so we have this vector here. Now, we are interested in finding the vector that is perpendicular to A, coplanar to A and B. So now, perpendicular to A and coplanar to A and B. So what do? We know that if C is coplanar if C is coplanar to A and B, then it means that C is equal to gamma A plus mu B. It means when you multiply A, vector A by any scalar plus vector B by any scalar, you have to get another vector. Okay, so that is what basically we are going to do here. And 2, they said we should find the vector that is perpendicular and coplanar. So let's talk about the perpendicular section. Okay, so also C is perpendicular to what? A. So that means that C times A is equal to 0. That is the statement. So this is equal to this is equation 2. Let me analyze the question again. If A equals this position vector, B equals this position vector, we are interested in finding the vector that is perpendicular to A and coplanar to A and B. So once you hear this, you have to think quickly about how coplanar vectors are. They are vectors that are on the parallel to a plane. So meaning they are linear combination of the other. So meaning that if you have A and B, that means there is another vector C. Okay, once it is coplanar, then there is another vector C. And they said it's perpendicular. A is perpendicular. Okay, so once it is perpendicular, it means the product of C and A must be equal to 0 because the angle between them will be 90 and cos 90 is 0. Okay, so let's dive into it. Now we have A, we have B here. Okay, so what can we do? We can do substitution from here. Okay, so we say that C dot A is equal to 0. So it means that wherever we see C dot A is basically 0. So here, let's do some substitution here. So let's say this is star multiplied by A because we have C equals this here and we have C dot A equals 0. So this will be equal to 0. Okay, so we expand it. We have y a dot A plus mu B dot A, and that is equal to 0. But we can obtain A dot A from here. Okay, so let's try to find A dot A. So A dot A will be equal to 8I plus 2J minus K. Okay, so A dot A, so times 2, right? Times 2. Okay, so we have 64 plus 4 minus 1 times 1 becomes positive 1. So we have our A dot A to be 69. Okay, so A dot A is equal to 69. Okay, so we have A dot A. Now we have B dot A here. So let's multiply A by B. So B dot A will be equal to 3I minus J minus 3K by A. And our A here is 8I plus 2J minus k. So we have that to be equal to 24 minus 2 times minus 1. Minus 2 times 2 becomes minus 2. Minus 3 times minus 1 becomes plus 3. So basically we have b dot a to be equal to 25. Okay, so we have b dot a, we have a dot a. So let's substitute into, let's say this is equation 3. So we substitute into 3, then we're going to have, okay, let me write that here first, equals 0. So substitute a dot a, which is 69, y plus mu, which is 20, b dot a is 25. So we have 25 mu equals 0. So basically, we can make 1 the subject. So making 1 the subject, then, okay, let's say we are going to make mu the subject. So making mu the subject, then we're going to have minus 69 over 25 mu. Okay, so let's consider this as equation 4. Now, we have equation 4 here, and we have this equation 1. So what can we do? The game is getting interesting. What can we do here? Oh, we can substitute equation 4 into equation 1 here, and we know our a here. Okay, so let's do that substitution. Let's do that substitution quickly. So we have c equals ya plus mu b. Okay, now we have mu over here, and we know b, we know a. Okay, so let's do that substitution. So we have y into a, and our a is what? 8i plus 2j minus k, right? Then our mu is 69 over 25, that is negative. So we have minus 69 over 25 mu multiplied by b. So all this multiplied by b, right? So that is what we have, basically we have here. Okay. Interesting. Okay, so what can we do here? What can we do here? What can we do here? Okay, so let's continue to simplify it further and see what we can have. So we have c equals gamma into 8i plus 2j minus k minus 69 over 25 mu 69 over 25. Oh, this is gamma. This is gamma. This is gamma. Okay, so we have gamma here, b. Okay, so this is what we have. Now we have gamma common to all the terms, so we do factorization. So that out, we have 8i plus 2j minus k minus 69 over 25 into our b is 3i minus j minus k. Okay, so this is what we have now. So we can say that c equals gamma into 8i plus 2j minus k minus 69 over 25 times 3 becomes minus 207 I over 25. Then minus 69 over 25 times minus 1 becomes plus 69 over 25 j. Okay, minus 69 over 25 times minus 3. So that becomes plus plus 207 over 25k. So this is what we have now. So the only thing we have to do now is to add the common position vectors. Add the common position vectors. Wow, good. So from here, we can say that our C is equal to gamma into 8i plus 8i minus 207 over 24. So that is basically 8 minus 207 over 25i, right? Plus 2j, the 2 plus 69 over 25 or j, right? Then we have minus 1 plus 207 over 25 or k. Okay, so this is what we have now. So now we add the values in there, add this argument, then we simplify what is inside the big bracket. So here we have C equals gamma into 8 minus 207 over 25. So that is basically going to be was minus 7 over 25 y into I minus 17 minus 26 minus 17j minus 26k. Okay, so this is what we have as our final answer. So you see, when you factor minus 7 over 25 out, then you're going to have your I inside minus, this is positive, so you have to make it negative here so that when it comes back, you have your positive 119 over 25, right? The same thing applies to this section, minus 26k. So when it comes back, you have your positive 182 over 25. So, ladies and gentlemen, this is the process that you go through to find a vector that is perpendicular to A and coplanar to A and B when you are given two position vectors. Okay, so that's the vector that is perpendicular to A and coplanar to A and B is given above. So for instance, if we know this scalar, this is a scalar, gamma is just a scalar. So for instance, if we know this scalar, then we can know the overall vector for this this C. Okay, so basically this is the process that you go through to find the vector that is perpendicular to A and coplanar to A and B when you are given two position vectors. First of all, note that if a vector is perpendicular to A, meaning that C dot A is equal to 0, and if it is coplanar to A and B, then you can say that there is a vector that is equal to, when you multiply a scalar by the vector given plus a scalar by the other vector given, it should be giving you an equation. So once you have these two equations, you can do your substitution, then you find the other vector that is perpendicular to A and coplanar to A and B of 0. So the product of the vectors produces 0. Okay, so this is the vector we have here and this vector we have here. Meaning that if we take the product of this, the dot product of A and B, we must result to 0. So the dot product of A and B must be equal to 0 so that we can have an orthogonal vector. So here we know that A dot B should be equal to 0. So once we know this assumption or theory, then we can go on and handle this problem. So we know vector A to be 2i plus aj plus k, right? Their dot product should be giving you 0. So times 4i minus 2j minus 2k. And that should be giving you 0. So, you multiply the corresponding position vectors. So 2i times 4i becomes 8. So, I times I is 1 because product of I times I, I is a unit vector, so its magnitude becomes 1. So here, we multiply A times -2, and that is -2A. Then 1k times -2k becomes -2, and that should be giving you 0. So here, we have -2A, 8 minus 2 becomes positive 6. So we have that equals 0. So we can say that minus 2a is equal to minus 6. Divide by -2 by -2. So we have, this implies that our a is equal to this takes of this. So we have 6 over 2. And basically, we know that 6 over 2 is equal to 3. Wow. So that is the process we go through to handle this particular problem. So we can say that the value of A is equal to 3, so that A and B are orthogonal. So that is the process. Thank you very much for watching. I really appreciate your time. Don't forget to subscribe, share with your mates, and I'll give you more updates. Bye-bye.